have originally, okay, when you're 9 or younger, I think probably most likely, again, this is something that we hypothesize will never confirm until you have brain surgery done, because this is very subtle finding. So MRI may not really show itself. But what we think is that probably when you're born with some abnormal brain on the right side, and this is not genetic condition. Okay, this is something that happened while his mother was pregnant with him. So in utero, when your brain was developing, there was some mistake happened, so that there was some mix-up of brain tissue in the right temporal lobe. Okay, now because he has so many seizures since age 9, now the right side seizure activity somehow is really triggering seizure activity on the left side. But for now, I don't see any evidence that the left side is independently causing seizures. I think it is all starting from the right side and then going to the left and having seizures. Make sense? Mm-hmm. So, so far what we found out is with all this testing, including MRI, PET scan, EEG, MEG, it suggests right side. Okay. So that's what we're going to go after. So we know the location. The issue is, okay, how much of right temporal lobe we need to take out to make him seizure free. Okay, there's no like one size fit all type of approach here, because everybody is a little different. The cause of seizures different and so on. So what I would recommend is we go with two-step surgery. Okay, so when I say two-step surgery, where's our brain model? Here. So this is brain model, and this is left brain, this is right brain. So far we know that your seizures most likely coming from here, temporal lobe. There's a very small chance it could be from frontal lobe. Okay. So what we want to do, so far everything is really just saying location. It doesn't say extent of it, okay? We're going to use this electrode. It's called subdural. The electrode is kind of a little broken. But this is essentially the same thing that we use in the operation room. We're going to open, we're going to do craniotomy and kind of flip open like that and place electrodes like this, okay? Yeah. And I'm just showing you one electrode where we're going to have to cover here, there, there. So just cover everywhere surrounding the focus, which is most likely temporal lobe. Okay. Now, once we do that, we cover up. So you're going to be waking up in the hospital like nothing happened. The only thing is you're going to have this cable coming out of your skull, and that's going to be connected to the EEG system. And we will stop your seizure medicine, and I'm pretty sure you will start having seizure right away. What happens is when he's seizing, his brain, this electrode is on top of the brain directly. So when his brain starts seizing, these electrodes, let's say hypothetically, is coming from the 3 and 11. You see that, 3 and 11? Mm-hmm. Then we know on the EEG, okay, 3 and 11 start, buzzing. And then when it's spread out, we can see, okay, it goes to 412, 513, and then stop at 614. All right? So that's when we know, okay, this is how much we need to take out.
And that would be part 2 of the surgery.
Mm-hmm.
Gotcha.
So
okay.
Once we get this information, the second part of surgery is take you to the OR again and remove as much as we need. We think it is necessary.